Okay, so we have these mathematical statements, right? And we have this sense of what true and we have some sense of what true and false means. But now I want to talk about sort of how do we build new mathematical statements from old ones? Because it's kind of what we were doing with that proof in the last class. But there's sort of more basic stuff. So that's yeah. So that's how do we build new mathematical statements from old. And a lot of these are like logical connectives. We use logical connectives. Like and or not. Those are the three super basic ones. And then implies also is going to be one of these, but we'll have to talk about what that means. So yeah, maybe I'll actually just include that in the list. Implies. Because I want to talk about each of these in turn. So and is just like, so what thing I'm going to do a lot here is we're going to have like P and Q are stand-ins for mathematical statements. Right. And so we have P and we can think about P and Q, which is only true if P is true and if Q is true, right? If Q is true. Okay, so that's not exactly hard to think about, but oh, by the way, notation books and stuff often write, you know, I think our textbook writes P like a caret Q, you know, like this right here. Oops. Trying to be fancy and do something like that, like change the color of that. Okay, so the book will write something like a little caret, and if you take like a logic class, like in philosophy, it's like all these like crazy symbols. I actually just like to write the word and because it's like not that hard, and it reminds you what it is. You don't have to remember like the caret is and then there's a little V shape which is or. So I tend to just write out the words. So I want to use this to illustrate the idea of what a truth table is. So truth table. So we can think of a statement like this as either being true or false, right? So that's like a possibility. Q is either true or false. And if you want to think about all the possible combinations, if you have two statements, they could both be true. One could one one could be true and one could be false. P could be false and Q could be true, or they could both be false, right? And so what we end up doing is we end up writing something like the following. We'll say, we'll make a table like this. So P and Q. And so I need to do all those four possibilities. So true, true is a possibility, true, false, false, true, false, false. Those are all the possibilities, right? See that the gallery's blocking my view of this. Okay, and so you can just fill this in because we using this idea up here, right? So it's basically only true if P is Q and Q is true. So we get, you know, true here, and all the other possibilities are false. Does that make sense? This is called the truth table for and. This is the truth table for and. Okay, fair. Any questions about that? That's just kind of like the basic, like the most basic truth table. So if we want to talk about a mathematical or, now here's where it starts to get slightly interesting, because or can mean different things. Or can mean either P or Q, but like not both. But mathematical or is actually what's called inclusive or. You may have heard the term exclusive or XOR. Mathematical or is, quote, inclusive or. So, so P or Q is true if either P is true or Q is true. Oops. Or Q is true, or both. I mean, that's kind of what I mean. Like, it's either one. Okay. So the truth table for this then is looks like the following. Making the nicer lines and notability. Like if I hold down. Oh no, it never works. Notability is like if you do this and hold it down, it's supposed to straighten out. There it is. It's really not worth wasting the time, but at least when we're together. Okay, so so again, you know, one way to read this up here, like I've made all four possibilities, but a way to think about it is like this is TTFF and this is TFTF, and that'll give you like all four possibilities if you just do that, right? Actually, I think our book does FFTT and FTFT, which I don't know. It's just the way I learned it was. So these may be upside down truth tables compared to the ones in the book, but sorry about that. But so now this is almost always true. The only way it's false is down here if both are false, right? Otherwise, it's true in the other three cases. Yeah. There is what's called exclusive or, XOR. I'll just put it down here. That's used a lot in like computer science and stuff. And so this one is, it's basically if one or the other is true, but not both, right? And so it's if they're, yeah, so this is actually considered false. So the truth table looks like that. Okay. Yeah. Then there's also like or is pretty easy. I'm not or, we just did or. Not is pretty easy. Basically, not is if something's true, if P is true, then not P is false. And if P is false, then not P is true. Oh, by the way, I forgot to say up here, the notation for P or Q sometimes that you'll see is like P wedge Q. So the little V. So V is, the little V is or, and the little caret is and. But again, most of the times I'll just write out the word. It doesn't take that much more effort. So yeah, sorry. So we have not. And this, it's really just, since it's just about one statement, it's not about combining statements. This I actually tend to write the little squiggle. It's, you could write, I guess I could just write not P if I wanted to, like not P. So if P is true, not P is false. And if P is false, not P is true. And again, this is often written not P, like with a little squiggle. Again, there's other notations. I mean, I've had students in the philosophical logic class come talk to me and start writing on my whiteboard, and it's like, looks like gibberish to me because the symbols are totally different what they use in that class. So, yeah. But any questions about that so far? I mean, a lot of this is just definitional. So what you can do then is you can start chaining these together and like making more complicated truth tables. So anyways, hopefully I'm not scrolling too fast through all this, but I think this is hopefully fairly intuitive. So before I talk about the imply symbol, which is really the interesting one, so more complicated expressions, we can build them, right? So like, for example, what if we wanted to know, like, say we had P, Q, and R as three different statements, right? So what if we wanted to do something like P and Q, or P and not R? Look, I just violated my thing and used the symbols instead of the words. P and Q, or P and, I guess I would put not R like that. So I'm just trying to, I mean, I guess maybe these symbols are useful for like shorthand and stuff, right? So what if I wanted to find, like, what's the truth table for that? Like, what combination of P, Q, and R being true and false makes this true? So now we can build the truth table. And now we have three statements. So we have P. Actually, maybe this is a good time to do the fancy lines. Hello. We have Q. And we have R. And now, what are the possibilities here? So how many possibilities are there with three statements for all the true false combinations? Somebody tell me. 8. It's 8, right? If I have 3 choices, if I have 2 choices, it's like 3 light switches, like one light switch for P meaning true or false, one for Q, and all the different combinations you can have is like there's 2 choices for this, 2 choices for this, 2 choices for that. So it's 2 times 2 times 2. Again, you can sort of systematically write this down by going like something like this: true, 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 false, 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 true, true, false, false, true, true, false, false, and then true, false, true, false, true, false, true, false. And I think this will give you all 8 possibilities. Maybe that's obvious to me because I've done it a million times, but right, you get every, it's sort of, if you just kind of do 4 trues and 4 falses and then do 2, 2, 2, 2, and then do all the individual ones, I think you get like, yeah, all the different possibilities of true and false there. Okay, and then if you want to actually build the truth table, you kind of have to build it in steps, right? So we could make a P and Q column. Right? I guess we need a not R column where we negate everything in R. We need a P and not R column to combine those. And then we need to OR these 2 columns together So you can sort of think about how you would build up to this. Again, this is pretty artificial right here because I haven't even given you statements, but when we start doing things with implication, there's going to be important truth tables we're going to build. So P and Q, we said, actually, maybe I should let you guys try to fill this in for a few minutes rather than just talk at your faces. Take a couple minutes and try to start filling this in, like fill in this column. Like you should be able to fill in this column based on just what the each P and Q possibility is, right? And then you should fill in this column by just negating everything in this column. And then you can do this column and then, yeah, see if you can build up. And you'll get some combinations of trues and false. Wish I could play like Jeopardy music or something. Just gets uninteresting for me at some point. Just waiting for you guys to just watch me fill these in. If you have questions, feel free to ask either, just straight up ask or put in the chat or something. I may be being obtuse in some way that I'm not realizing, and this is very confusing, but you should be far enough ahead of me that I can probably fill in this first column. So oops. True and true is true, true and true. Everything else is false, is that right? Not R. It's just sort of flipping all the trues and falses in the R column. P and not R, you need to do a little more. I have to actually look back and forth probably. So I need them both to be true, otherwise it's false, right? So P. Okay, but that one's true because they're both true. That one's false. And hopefully you guys are checking me. I think the rest are all probably false. Is that what people have? Yes, I got a couple of thumbs ups. Awesome. Okay, and then we need to OR these two columns together. So really it's, if we see a true in either place, then it's true, right? So true here. Actually, does someone want to be brave and read their column? I'll try to copy you. Volunteers.
Yeah, I can go.
Okay, great.
So we have true, true, false, then true, and then the rest are false.
And the rest are false. Cool. Is that what other people got? Awesome. Yeah. That's funny because I usually expect ORs to have more trues in them, but I think you're right that like down here, this is all falses down here, and this is and these last four are all false, and these last four are all false. So that makes those all false, and then we also get a false here. So yeah, so this is the way, and again, like this is sort of empty of content right now, so it seems a little bit arbitrary, but you just kind of see how the mechanics work, right? Any questions?